Now, coming to what I can say, still for the what you can that is about the de Broglie's concept, we will see one experiment, that is division and Germer's experiment. Now, what this experiment will verify? It will verify the dual character of electrons. It is going to verify mathematical relationship. Already we have seen it. We have understood dual character of electrons. It is going to verify. So, division and Germer did further experiment to verify the dual character of electrons. Mind it. So this is the incident ray, any ray, that is the sun's ray, the incident ray, and this is the reflected ray. Now you can think that, sir, one ray, so many rays is coming on. No. Here also not one ray is there. For explaining, I have taken it as one ray, because if I take many rays from here, then you will be confused. For that reason I have taken it. So number of rays, because it's not possible to get one ray, you know that. Theoretically we are doing it, practically it's not possible. So don't get confused. So an incident beam is coming, I should say that, incident ray is coming, and the reflected ray is coming out from this. From where? That is a nickel crystal I have taken, a metal crystal. He took a metal crystal, that is a nickel crystal. So when the incident ray is allowed to fall on the nickel crystal, nickel why he took it, metal why he took it, because you know the surface of the metal has got a metallic luster, it shines. So it behaves like a mirror, you know that particular thing. So hence here the reflected ray comes out. He now collected this reflected ray on a photographic plate. He collected it on a photographic plate. Now, when he collected it on a photographic plate, this is a photographic plate he placed, and when he collected it on a photographic plate and he observed it under a microscope, he got, listen carefully, he got a diffraction pattern of rings. Diffraction. I am saying the word, what I am saying? Diffraction. This word you will be getting it in physics. Diffraction, interference, in light chapter you will be studying. This is a diffraction. This pattern of ring is called as a diffraction pattern of the rings. Alright, he got it on the screen. Clear? On the photographic plate. What I said, he took the photographic plate and he observed this photographic plate on a microscope, on a powerful microscope. He observed it. So, what he got is that he got nothing but the diffraction pattern. This sort of rings he got it. He saw on the, what you can say, on the microscope, by the help of microscope, he saw it. Now the question is, where the waves had gone? That's it, what I said. Where the waves had gone, that is what I need to explain it. That these waves are converted into ring-like, isn't it? What Niels Bohr said, that electron is moving in a particular shell. So shell was circular, but actually not circular, it is spherical. Definitely, that is spherical. That we can correct it. It is spherical. So this is nothing but a shell, and this is nothing but made up of what? Energy. And here the electrons is moving. When the electron is moving, it is describing a path. What is that path? Wave pattern. So that wave pattern, when we see by help of, now waves you cannot see, no, it is cannot be seen with the naked eyes. Alright. So hence what we see, instead of getting the waves, that waves is converted into rings, and hence we see the diffraction pattern of the rings. But this rings, how it is formed, listen carefully, it is being formed with the help of waves. Now we will prove it also. The rings are being made up of what? Waves. Waves are not visible because it is very, very small, so it is not visible to us. By the help of naked eyes, it is not visible. So these rings are being converted into diffraction pattern of waves. Mind it, diffraction pattern of waves of alternating intensity. Alternating intensity means alternating waves. This is known as alternating intensity. You have studied all this about in the, what you can say, Planck's quantum theory. You have studied about intensity. So in this way, this was the observation got by Division and Germer from his experiment, which clearly shows that a particle is of, what you can say, an electron is of dual nature. It is both particle nature as well as wave nature. It shows clearly particle nature because when light is falling, the particles these particles are being released from the surface. From there it is a particle nature. Otherwise, how you are getting this reflected ray? Unless and until the particle is not given. So when this particle are released, when the particles are leaving from the surface, alright, when it is leaving from the surface, mind it, one more thing, that is these rays should have a minimum energy. That already we have studied in photoelectric effect. That you must remember it. That these rays should have minimum energy. Then only the electrons will be ejected from this particular surface. That you should keep in your mind. I am not saying that. That you should keep in your mind. So that is particle nature, and hence this particle nature we are getting in the form of diffraction pattern of rings in the photographic plate when we observe it in a microscope. What is that? It is wave nature. So clearly it is verified that electron is of dual nature, that is particle nature as well as wave nature. Alright. now we have to see that what you can say, if it is of wave nature, then it should obey one of the postulates, one of the theory given by Niels Bohr. What is that? That angular momentum is quantized. mvr is equal to nh by 2 pi. You remember it, I said you that where from he got this value? Niels Bohr could not say yes. Now I'll explain it from where he got this particular value. See here. If you consider it is as wave nature, let us say I am considering it wave nature. Alright, this diffraction pattern, one of the diffraction and pattern I am saying it is of wave nature, means it consists of waves. Let me draw the waves and see. See, this is the waves I am drawing it, the crest and the trough. One, two, three, four, in this way. See, it is complete, the crest and trough. It is complete. This particular one I can make it little bit better. I am not good in drawing. Yeah. So in this way you can see a complete wave we got it. Now this particular, in this way, different diffraction pattern will have different type of wave pattern, correct? So here how many waves are there? N number of waves are there. What is the wavelength of each wave? Each wavelength, you know, this is one crest and this is one trough. So what is the wavelength? Lambda. Alright. This particular circle, alright. Let us consider circle here. This particular circle consists of how many waves? N number of waves. How will I know how many waves are there? N number. Now here you will say, sir, you can count and you can find it out. Okay, done. But theoretically, can you count it? No, it's not possible because you are seeing the diffraction pattern. Mind it. Here for your explanation, to explain you, I have done the waves. To explain you. But rather, can you see the waves there? No, we see the diffraction pattern. So what I say is that this particular circle consists of n lambda. This n lambda is nothing but 2 pi r. Because what I said, the circle. What is circumference of the circle? 2 pi r. We know that circumference of circle. That is nothing but n lambda. See here. This is one wavelength. This is another wavelength. This is another wavelength. So it constitutes a complete circle, which is nothing but n lambda. Can we equate it or not? Yes. 2 pi r is equal to n lambda. Now, instead of lambda, we can write h by mv. Where from we got it? De Broglie's concept. De Broglie's concept we got it. Lambda is equal to h by mv. So nh by mv. 2 pi r is equal to nh by mv. Now, what we do is that we will take mv and multiply with this. So, what we will get? mvr. And here we get it nh. And 2 pi we can bring it down. Yes or no? mv into r. So, mvr. 2 pi will come down. So, nh by 2 pi. So, we got it. mvr is equal to nh by 2 pi. Which was not explained by Niels Bohr, which was explained by de Broglie. We can say that. So, de Broglie explained this concept. mvr is equal to nh by 2 pi. Alright? Clear? So, from the Davisson and Germers experiment, we came to know about the dual nature of matter, that is particle nature as well as wave nature. And further, it was also, we got it, not corrected, I should use the word, rather further we got it from where he got the postulate, where he got the formula that angular momentum is quantized, mvr is equal to nh by 2 pi. I said you that particular time. So whatever the scientists, they considered it, later on when it was being calculated, it was seen more or less it is correct. So you see here, what Niels Bohr considered it. Niels Bohr did not have any mechanism, but he, upon his concept, he considered that angular momentum is quantized and he gave us the formula. And when Davisson and Germer along with the de Broglie, when they found it out, they found the formula is absolutely correct. mvr is equal to nh by 2 pi. In this way it solves. Alright? Thank you very much.